Hi guys, this is an exciting day for you because we're going to learn about a new type of numbers today, and this is a type of number that will be around from here on out, and it's exciting because it's called imaginary numbers. So today when you go home, or I guess tonight when you're watching this video and your parents say, well, what did you learn about today? You said, I learned about imaginary numbers. Just sounds kind of fun. So I think you will like this section, and the math's not that hard behind it. It's just a new type of number. Okay, so what's an imaginary number? Well, here's the deal. You are not allowed to have a negative number under a square root sign. So somebody asked me this yesterday actually. When we did the quadratic formula, what would happen if something like negative 64 showed up underneath the square root? Okay, that will sometimes happen when you use the quadratic formula especially. But this is not something that we can solve up to this point, because usually when we do square roots we're saying, well, what times what, that's the exact same number, will equal negative 64. And this can't be the case because they would both have to be positive or they both have to be negative. And they have to be positive. There's no way I can have the same number being multiplied twice and end up with a negative number. So to solve that problem, we have something called imaginary numbers. We can take out this negative sign because we all know what the square root of 64 is. The square root of 64 is 8. So the thing that is causing us this hiccup is this negative sign. We can take out the negative sign from the square root if we put an I in front of the square root. And basically it's like, okay, we just took out this negative, so this is now an imaginary number. This is not a real number. Okay, these are not real numbers. The only thing we're going to do is we're going to take out this negative with it. So the square root of negative 64 is actually 8i. Okay, here's the rule that you need to know. The definition of I, and I'm sorry that kind of got cut off there a little bit. Oh, I can't fix it even. Okay, I is the square root of negative 1. And because of that, I squared is negative 1. These two facts you use all the time, so you need to have those memorized. And it will be easy to do after we do our homework today. So we're going to jump right in there and do some of these problems because all the rules and properties are going to apply. And you just need to remember these two facts. I equals the square root of negative 1. I squared is negative 1. And everything else will be old stuff today. Nothing real new. Okay? So we're going to solve for a here. A squared equals 21. I don't know if you can read this. I better write up here. A squared equals 21. How do I solve this? I take the square root of both sides. Remember, when you have a number that is squared and the square root, that becomes the absolute value of a equals the square root of 21. If there are two bars, there are two answers. And some of you are forgetting the two answers here. This is going to be plus or minus the square root of 21. That cannot be broken down. 21 does not have any perfect squares that go into it. Now this one's a little different. A squared equals negative 21. Square root both sides, square root both sides. I have the absolute value of a equals square root of negative 21. This negative causes us some problems. There are still going to be two answers here, so it's still plus or minus. But now we're going to say I square root of 21. You got to pull that negative out. You cannot have a negative underneath the square root. Okay, let's look at, I'm going to pull up a box here to write over this next one. Okay, p minus 0.2 squared equals 0.81. Step 1 is to isolate the square, and it is. From here we could take the square root of both sides. I now have the absolute value of p minus 0.2 equals the square root of 0.81 is 0.9. 2 bars means two problems. So what are my two problems? Well, p minus 0.2 could equal 0.9 because this quantity in here could be 0.9 or it could be negative 0.9 to make this work out. And like we just said, the other problem would be p minus 0.2 equals negative 0.9. Add 0.2 to both sides. P equals 1.1. Or p equals negative 0.7. These are problems that we have done already. This is like something we did early on in this chapter. Okay, it's a little bit different if, oh, that works out good. It's a big eraser. p minus 0.2 squared equals negative 0.81. Square root both sides. Again, that becomes the absolute value of p minus 0.2 equals, we already talked about this. What is this going to equal? This is going to equal 0.9i, because that square root of negative needs to come out. That's where the I is coming from. Square root of 0.81 is 0.9. Two problems. P minus 0.2 could equal 0.9i, or p minus 0.2 could equal negative 0.9i. You can have a negative I. That is legal. You just can't have a negative under the square root. So we solve this. And here's the tricky part. Numbers go with numbers, x's go with x's. You guys know that from your basic algebra days. But the same is true with imaginary numbers. So my first answer is going to be 0.9i plus 0.2. Add 0.2 here. And my next answer is going to be p equals negative 0.9i plus 0.2. You cannot combine real numbers and imaginary numbers. They're not like terms. Okay? What should I do? Can I make that go away? Okay. 3x squared plus 363 equals 0. They want us to write the solutions. You have a couple of options here. It does equal 0, so you could do the quadratic formula. Although I'm just going to solve it by getting the x squared by itself. 3x squared equals negative 363. I'm subtracting 363 from both sides. Divide both sides by 3, and I get x squared equals negative 121. They want us to write this with a radical sign. Okay, so we square root both sides, square root both sides. I don't exactly know what they want us to do here. Absolute value of x equals, I would say that's 11i. There's two possibilities because of the absolute value, so it's plus or minus 11i, but that is without a radical sign. So I guess the other way they want you to do it is write plus or minus square root of negative 121. That's just not a very nice way to write it. Maybe they want plus or minus I square root of 121. Either way, your best answer is plus or minus 11i. I don't know what the purpose of having you write it with a radical sign is, but maybe they have some meaning. I don't know. Okay. Pick and choose. I am going to work through all these. You guys need to pay attention to the ones that you feel that are necessary. Square root, and I don't know if you can read these very well, so I'm going to rewrite everything right above it. The square root of negative 81, we just talked about that. Negative, that makes it an I. Square root of 81 is 9, so we could say 9i. I don't know what the square root of 2209 is. Breaking out my calculator here. 47 has a negative here, so this is the square root of negative 2209. I said it's 47, and then it has to be imaginary because there's a negative under here. This one is a little different. Square root, negative square root, negative 9 over 16. This means my answer is going to be negative when all is said and done. It's going to have an I involved because there's a negative underneath the square root. Square root of 9 is 3. Square root of 16 is 4. So negative 3/4 I. So there's a negative here, and there's a negative here. This is the negative in front. This is the I, and on the square root of 9 over 16 says 3/4. Okay, now what they're asking us to do is to break out the part of the quadratic formula. This is actually called the discriminant. We'll talk about that later this chapter. B squared minus 4ac. We're going to plug in A, B, and C. And here I have A equals 10, B equals 8, C equals 2. Square root of B squared is 64 minus 4. A times C is 20. Square root of 64 minus 80. Square root of negative 16. Negative means it's imaginary. Square root of 16 is 4. My answer is 4i. Okay? If I have a equals negative 2, b equal negative 3, and c equal negative 5, plug that in. B squared, negative 3 squared is 9. Minus 4 times a times c, that's positive 10. Square root of 9 minus 40. This one won't work out nicely. Square root of negative 31. 31 cannot be broken down, but I can take out the imaginary part here. So my answer is going to be I square root of 31. Usually, as a rule, I put the I in front of it if it's a square root, because otherwise it gets confusing unless you put the cap on your radical sign. And if it's a whole number part, we can put it in front. Now these look difficult, but they're not. I'll clear the annotations here. 7i minus 3i plus 5i. Just treat them like they're x's. 7i minus 3i is 4i. 4i plus 5i is 9i. Okay, I'm going to do these evens first. 3i times 5i. That's 15i squared. Yes, I can be squared, and if you remember, I squared is negative 1. So this is 15 times negative 1, which is negative 15. Okay, how about this one? 18i over 3i. Just divide. The 6's, the i's cancel out, and I'm just left with 6. (17i minus 12i) all over 10i. That's 5i over 10i, which is, the i's cancel, 1/2. Okay, now let's look at the parts that have the square roots involved. The math will be very similar. We just have to get to the i's first. 3 square root of negative 4 minus 2 square root of negative 25. This is 3 times square root of 4 is 2, and it is an imaginary because of the negative. Minus 2 times square root of 25 is 5. It is imaginary, 5i. 6i minus 10i, negative 4i. Square root of negative 16 times square root of negative 49. 4i times 7i, 28. I squared. I squared is negative 1. 28 times negative 1 is negative 28. You will get very good at these the more you do. Square root of negative 144 over square root of negative 81. 12i over 9i. The i's do cancel. They have a 3 in common. I'm left with 4/3. And last but not least, I don't know if there's any on the next page or not. I have square root of negative 16 plus square root of negative 9 all over 5. 4i plus 3i over 5. 4i plus 3i is 7i, still over 5. Nothing can be simplified there. Okay, and I think that's all. Yeah, it is. And I think you'll find the homework very easy on this section. Imaginary numbers are fun!